Welcome to the egg drop preparation video number 2. In this lesson, we're going to learn some additional equations, such as how to figure out how fast the egg is going when it hits the ground. We should know how to calculate energy now. In the last video, we did potential and kinetic energy. Let's move on to other things that we're going to need to know. So we know that kinetic energy and potential energy will be equal to each other. We also know that the equation for kinetic energy is 1/2 times the mass times velocity squared. We can use energy to figure out the speed of the egg. So remember, for a 60-gram egg, the potential energy equation, mass times gravity times height, will look like this, giving us 3.42 newtons of energy. That potential energy will be converted to kinetic energy as it falls. Remember, the potential energy is at the top. The kinetic energy will be developed as it falls to the bottom. So if the potential energy at the top is equal to 3.42 newtons, that means the kinetic energy at the bottom will be the same amount. We can use this to figure out how fast it's going. So we know that kinetic energy is 3.42 newtons. If we apply that to the equation we know, we can solve for velocity. So in this equation, you see we have kinetic energy is 3.42 newtons. That is equal to 1/2 of the mass times velocity squared. 1/2 of the mass is 0.03 kilograms. If we divide that from both sides, leaving velocity squared by itself, we have velocity squared is equal to 114. When we take the square root of both sides, that tells us that the egg was moving at 10.68 meters per second. Let's do it again with the new numbers and see if we can figure out the velocity. So we have to have the mass converted to kilograms. So 75 grams is 0.075 kilograms. We'll say that we're dropping it from a height of 6.5 meters. We use this information to figure out the potential energy at the top. We use the potential energy and make it equal to kinetic energy. We then overlap that number with the equation for kinetic energy. When we multiply the mass by 1/2 and then divide it from both sides, all we have to do is square root, and that will give us the velocity. So how are we going to keep our egg from smashing at the bottom? We know potential energy, we know kinetic energy, but we know it still spells disaster. So to reduce the amount of energy, we have to either decrease the velocity or find a way to absorb that energy upon impact. These are things we'll have to consider when designing your contraption. Let's review. If you have a 50-gram egg and it's being dropped from 7 meters, what will the velocity be as it hits the ground? The 50-gram egg dropped from 7 meters would have a kinetic energy of 3.5 newtons and therefore a velocity of 11.83 meters per second. If you could slow the fall to a velocity of just 8 meters per second, what would this do to the kinetic energy? So if the original kinetic energy was 3.5 based on a velocity of 11.83, then slowing the velocity would in turn reduce the kinetic energy. This could protect the egg when you drop it. Thanks for studying with me today. If you need to rewatch this video, do so, and keep these calculations in mind when you get ready to do your egg drop.